In this segment, we're going to be talking about subtracting mixed fractions. And again, it's important to stress that when we add or subtract things, we can only add things or subtract things that are the same. So the kinds of things that are the same are our whole numbers. We can add whole numbers together. And if we want to add fractions or subtract fractions, they have to have the same kinds of things, the same shapes, or the same denominators. So our first question is going to start off with a mixed fraction with the same denominators, and we'll work on to having mixed fractions with different denominators. Our first question is going to be 3 and 5/6, subtract 4/6, or another way of saying it, I'm going to take 4/6 away from 3 and 5/6. And by saying it that way, 4/6 away from 5/6, I can see that I'm going to have 1/6 left over, and so I can go ahead and do this quite quickly without needing any kind of borrowing, etc., to get the answer 3 and 1/6. And this might be what our work would look like. We have 3 wholes, subtract no wholes, so 3 subtract 0 is 3, 5/6 take away 4/6 is 1/6. I combine my two pieces together and I get 3 and 1/6. So now I'm going to show how we might be able to show that question with the fraction blocks. So I've got 3 wholes, 1, 2, 3 wholes, and 5/6. Our blue shapes here are 6 because it takes 6 of these shapes to fill up our double pink. So we've got 1, 2, 3, 4, and this pair makes 5. So we've got 3 wholes and 5/6, and from that I want to take away 4/6, so I can pull away 1, 2, 3, 4, so I take those away, and I'm left with 3 wholes and 1/6 left over. So my answer is 3 and 1/6. I want to take a second just to show another way of doing that. Lots of students and some teachers also like to change them to an improper fraction before we go to subtract them, and that will work. So I've got 6/6 here, so there's 6. Another 6 gives me 12. Another 6 gives me 18, plus my 1, 2, 3, 4, 5 gives me a total of 23/6. So my question could be written this way, and 23/6 take away 4/6. Again, if I take my 1, 2, 3, 4 away, leaves me with 6, 12, 18, 19/6. And 19/6 can be rewritten from the improper fraction to our mixed fraction of 3 and 1/6. And that technique will work. However, as you see that the numbers get very, very large quite quickly, and if I was to give you something more like if I had 27 and 5/6 subtract 4/6, do I really want to switch 27 and 5/6 into 100 and something sixths, when we can see here that all the actions happening over here in this fraction piece, my whole pieces aren't really involved at all except for this very last piece. And so I think it's important that when we're introducing this with children, if the fractions are small, we can show this, change it to an improper fraction technique. And we can talk about how that works, because we're going to end up having it when we have to borrow, we're going to make one of the fractions improper anyway, but we don't have to make all the pieces, all the whole numbers, to be improper fractions. And I think that's important for students to recognize. If we give them all little tiny numbers, then they want to switch them all to the improper fraction, and it works fine. If, however, we're using larger numbers, and I think we should every once in a while, to show them that it's really the actions all happening on the last fraction piece or on the last whole number piece, I think that would serve our students well. In our next question, 2 and 1/4 take away 3/4, or subtract 3/4, or 3/4 from 2 1/4. We often see this very common mistake. Students will go 2 1/4 subtract 3/4. They don't really sure what to do with the 1/4 take away 3/4. So what they do is they just say, well, 3 minus 1 is 2, and so I would have 2 wholes and 2/4. And that's a very common error. And if we use the manipulatives, we can see that that error won't occur as much. And so I think it's important to be familiar with the kind of error that you're going to see. That's a very common error. So let's do this question with some manipulatives. So here we have our 1 whole, 2 wholes, and 1/4. If we draw it out this way, we can see quite clearly that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters. 9 quarters take away 3 quarters is going to give us 6 quarters. And so our work might look something like this. Our 6 quarters is now changed to 1 2 quarters, or 1 1/2. If, however, we represent this question this way, 1 whole, 2 wholes, and 1 quarter, and now I want to take away 3 quarters, which means I want to take away 3 reds, I can see that I don't have enough reds to take away. So what I can do is I can take this last whole number and change that and convert that into reds. So it's going to take 1, 2, 3, 4 reds to convert that one. So I still have my 1 whole, 2 wholes, and a quarter, but now I've basically got 1 whole and 1, 2, 3, 4, 5 quarters. I can take my 3 quarters away now, so I take out my 1, 2, 3 quarters, and I'm left with 1 whole and 1/2, which is what I said my answer was here, 1 1/2. And this shows how we use the fraction blocks and how we represent our fractions really makes a big difference to the students. When I changed them all to reds, it looked like it was very easy to see 9 quarters, and I could pull away the 3 quarters and leave me with 6 of the reds. When I represented it as my wholes as being yellows with my 1 red, it really looked more like 2 1/4 as opposed to 9 quarters. And how we use our manipulatives to represent the numbers makes a big difference to the student as to how they see the fraction. In this question, 3 2/3, subtract 1 3/4, or 1 3/4 away from 3 2/3. It's a little harder to see what's going to happen here. I know I've almost got 4, and I've almost got 2, so 4 minus 2 should give me an answer of about 2, and so I'm not 100% sure what it's going to be. I'm not really sure if I need to change anything because I don't have common denominators, so I can't tell if I need to borrow some or not. So again, this just reinforces the idea that before we can figure out what we have to do, we have to make sure that we're talking about the same kinds of things. So therefore, the first step we have to do in this question is make common denominators. And if we were using the fraction blocks, we have to make sure we have the same colored shapes. So I'm going to start off with the fraction blocks. And here it is represented. I've got 1 whole, 2 wholes, 3 wholes, and 2/3. Each of these blocks is a third. So it gives me 2/3, and subtract 1 whole and 3/4. And I can't subtract my reds from my blacks because they're not the same shapes. And so therefore I have to make common denominators or the same shapes. And I can make those out of the following. And the only shape I can fill them in is with the green triangles. And so the green triangles are 12ths. So now I have 1, 2, 3, 4, 5, 6, 7, 8 12ths. And I want to take away 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. So I don't have enough 12ths here, so I'm going to have to borrow. But before I do that, what work would I have to show? And I might expect something that looks like this. 3 8 12ths subtracts 1 9 12ths. And I can see that I cannot take 9 12ths away from 8 12ths, and so this is what's going to cause me to have to borrow. Again, I don't have to change my entire diagram to green triangles. I just need to change one of my wholes into green triangles in order to do that. So here I've changed one of my wholes into the green triangles. So we might show something along this line. We cross out the 3 and we replace it with a 2. And we have now 12, 13, 14, 15, 16, 17, 18, 19, 20. And so instead of 8 12ths, I now have 20 12ths. Because I've crossed out the 1, I've borrowed 12 12ths, which is this hole here, and now I have 20 12ths. And now I can want to take away my 1 9 12ths. 20 subtract 9 is going to give me 11 12ths, and 2 subtract 1 is going to give me 1. So with my diagram here, I could show either taking away the 9 12ths either as just taking them away, or I could think of them as taking them away as a pair. So this is what I have to take away. So there's one pair, there's the other pair, there's the next pair, and so on, and so on, until I've taken away all the greens that are covering up my reds here. And what I'm left with is now 2 wholes and 6, 7, 8, 9, 10, 11 twelfths. So I'm going to be left with 2 wholes and 11 twelfths, and now I want to take away my wholes, and so what I'm left with now is 1 whole and 11 twelfths. And it might look something like that. So in this segment we've talked about subtracting mixed fractions with common denominators, subtracting mixed fractions with common denominators where we require some borrowing, and we've talked about in this last question subtracting mixed fractions where we require with different denominators, which requires them to change them into common denominators before we even need to see or to show that we need to borrow. Then we borrowed them and remove them for an answer of a mixed fraction with a whole number and a proper fraction in our answer.